Hello all, my name is Pradeep Chavan and today we are going to see 7 QC tools. Quality Guru from the Japan, Kaoru Ishikawa said 99 of quality problem can be solved with 7 fundamental tools. So which are these 7 fundamental tools or QC tool? So these are 7 fundamental QC tool. It is also called as a 7 QC. Flowchart, check sheet, Pareto chart, cause and effect diagram, histogram, scatter diagram, and control chart. So let us see flowchart. Edward Deming, who is a quality guru from the USA, said if you can't describe what you are doing as a process, then you don't know what you are doing. And the best way of describing what you are doing is a flowchart. Flowchart is a usual tool that depicts the flow or the sequence of the processes. For example, information, task, people, material, and decision. Flowchart will bring everybody on the same platform and promotes the common understanding. Makes the complex simple become simple. So, complex problem or the thing will become very simple by the flowchart. So, this is an example of flowchart. So, there will be symbol. For example, start, end, then process, then decision. There will be arrows. So let us see one example of the flowchart. Suppose you wanted to manufacture this kind of pin. So raw material will be there and grinding will be process applied and you will get this kind of pin. So this is a simple example. That's why it is taken as an example. So flowchart will be prepared. Basic symbol will be like this. This is a processing symbol. Then this is a decision step or the, for example, whether it is a defect, whether it is okay not okay, that kind of decision symbol will be there. Then basic arrow line symbol, then start and stop symbol will be there like this. Now initially material will be received or rather work order will be received. So as per the work order, inspection will be happening. Then decision will be taken depend upon the output of the inspection whether it is okay or not okay. If it is okay, then it will be going for the next process, that is a grinding. If it is not okay, then that material will be rejected. So after grinding there will be final testing. Again in the final testing there will be inspection and it will be judged whether it is okay or not okay. If it is okay, then it will be sent to packing and distribution and order will be completed. If it is not okay, then material will be rejected. So this is a simple example of the flow chart. Now if you want to monitor this process after final testing, whether there is a defect or not. So for that, check sheet is the best tool to monitor that particular process effectiveness or the quality of the product. So let us start with our check sheet, that is the next QC tool. So what is a check sheet? Check sheet is a simple tool for collecting, organizing and analyzing the data. It makes easier to identify the pattern and the trend. By organizing the data in a clear format, the check sheet helps team make the informed decision based on the factual information. It should cover following: who collected the data, when, including date, shift or time the data was collected, where, that is a location, line, equipment, number for the data that is collected. Now this is the example of the check sheet. If you arrange as per your convenience, now it is not needed to have the fixed format. So that format can be decided as per the user convenient so that the data can reflect and can be analyzed easily. In this example, you can see the model, part number, part name, operation, operator, then location, then serial number, what are the defect, and date wise rejection you can see from the Monday to Friday, what is the total. Here you can see major contributor is the ovality, second is the diameter. So such kind of primary analysis can be made by effective use of the check sheet. Now you can put the effort for this particular defect and you can eliminate the root cause and you can eliminate the defect. But for the each and every causes you cannot put the effort. So there will be the priority will be decided where you have to put the effort, because we have got the limited resources including manpower and the time. So Pareto diagram will help for this purpose. So let us go to the next tool, that is a Pareto chart. So I will go to the next slide. Here it is. Pareto chart is a bar chart that allows for the analysis of the data in search of Pareto principle or the 80-20 rule. The 80-20 rule was first identified by the Italian researcher Vilfredo Pareto. The 80-20 rule was popularized by the Joseph Zoran to help us separate the vital few from the tribal many. So what is the meaning of this? Simple meaning is this: 80% defect are produced by the 20% causes. Are you getting me? So there will be 20% causes will be there which are producing 80% defect. So this is called 80-20 rule. So here you can see the example for the Pareto chart. Here defect are mentioned. Here total quantity produced, rather defective quantity is mentioned. Then this is a percentage. This is a cumulative. So here you can see this ovulated diameter and burr are the major contributor. So they are contributing up to 80%. So what is a Pareto? They are saying these 80% defect are produced by 20% causes. So this is the 80-20 rule. Now you need to focus on this 80% defect because you require less effort. Only 20% causes you have to for which you have to work, and you have to find the root causes. So for the finding out the root causes, our next tool will be important or will be used. That is called a fishbone diagram or the Ishikawa diagram. It is also called as a cause and effect diagram. Here example is shown: defect, ovality, diameter, burr, surface finish. These are the defect. How much quantity related to that defect is mentioned here. The percentage of defect, how percentage calculated? You can get the total, and individual can be divided by a total into 100, that percentage, and cumulative. So how cumulative will be added? This is 33, then 33 plus 27, 60, again 60 plus 20, this 80, and how this cumulative will be calculated. This is how it will be calculated. Now what Pareto is saying, now here you can see ovulated diameter burr are these defect which are contributing 80%. So that will be produced by 20% causes. Now here you have to identify the cause, you have to use the tool, for example fishbone diagram, and this is our next tool from the 7QC tool, fishbone diagram, or the it has also said cause and effect diagram or the Ishikawa diagram. So this is the example of the cause and effect diagram or the fishbone diagram. So first of all you have to define the problem. So here problem will be defined here at a central, for example defect. Now we have to identify the major category, for example man, material, machine, method, environment. Then you have to brainstorm potential causes. Now there will be CFT. So it is not possible that one person knowing each and everything. That's why CFT involvement is required. So each area will be one person from each area will be taken as a safety because he knows the detail of that area. Then you have to analyze and prioritize the causes. So which are the potential causes? For example, material related, what can be gone wrong, what thing can be gone wrong related to man, machine, method, environment. So for that you can use the flow chart, you know. So what is the requirement, what is not happen, so that can be analyzed. Then you have to analyze and prioritize, you have to collect the data and you have to see, and you have to see what are the potential causes. For example, in the machine there is a pressure variation, maybe the potential cause. So data will be analyzed, expert opinion or the person from that particular area will be having a meeting and the brainstorming will be there, and you have to prioritize the cause, and you have to test whether this pressure variation is a really cause for that particular defect. So for that it is scatter diagram will be helping us, and that is leading to our next quality tool, that is a scatter diagram. A scatter diagram is a usual analysis tool that shows the possible relation between two variables. Now here you can see diameter and the pressure. These are the two variables which are taken on the y-axis and x-axis respectively. So here you can see diameter and pressure and graph is drawn. Now what is the use of this? You can see whether there is a real correlation between these two variables, and you can decide the tolerance of the second variable. For example, you have got a diameter which is having the tolerance 9.98 and 10.02. So corresponding value of the next variable, that is the x-axis variable, can be identified to corresponding that particular lower size and the higher side. For example, 9.98 diameter is having the corresponding pressure limit 4.3 bar, and for the 10.02 value corresponding pressure limit is a 4.7 bar. So you can decide the tolerance for that particular thing also. So here theoretically I have drawn this, it is having the perfect correlation, but practically there will be no such a perfect correlation. There will be some kind of Persian correlation coefficient will be there. So if it is r equal to 1, then for perfect positive correlation will be there. If it is a highly positive correlation, that is r equal to zero point 0.8, and the thumb rule is that it should be more than zero point 0.8. So if it is 0, then no correlation at all. So if it is negative correlation or the r equal to -1, so that will be the correlation. Now this is all about the scatter diagram. Now suppose you wanted to see the trend of that particular diameter, then that will be help us by histogram, and this is our next QC tool, that is called histogram. Histogram is a type of chart that graphs the frequency of the occurrence of continuous data and is useful tool for the displaying, summarizing and the analyzing the data. The best way to see the pattern of variable is a graph your data using a histogram. So this is the example of histogram, and you can see the pattern, you can analyze the pattern. For example, symmetric unimodal pattern is example here, skewed right, then non-symmetric or the bimodal pattern is here, uniform pattern, skewed left, symmetric bimodal. So these are the various pattern or the different pattern that can be analyzed by using the histogram. And the most important thing, you can fix the limit, that is upper specification limit and lower specification limit. So whatever points are lying in between, that will be in acceptance zone, and outside this limit will be rejection zone, and that will be leading to our next QC tool, that is called a control chart. Control chart allow you to ensure that your process is in control or the stable. Control chart is a usual combination tool that reflect the performance and behavior of your process. Example is here, unstable process, not consistent over time. Here you can see distribution. There is a range variation you can see. At the same time, it is sometimes it is shifted from the mean, sometimes it is left side, sometimes it is right side. So what is the example of stable process? That is a consistent over time. So here you can see x is almost stable, even range variation is less. So how it can be monitor? There will be upper control limit, there will be lower control limit, and the normal process variation will be lying in this limit. So if it is crossing any point, here you can see point is cross, so that will be special cause variation, and you have to remove the special cause variation. You have to ensure only normal process variation is there. So for that you have to draw the control chart, and this is the application of control chart. Okay, that's all from my side. Thank you very much for joining this session. Thank you.